Welcome to day 11 of our Python course. Today we will be exploring sets in Python. A set is an unordered collection of unique elements, meaning it does not allow duplicates. For example, my set contains the values 1, 2, 3, 4 and 5. Let's dive deeper into what makes sets so useful and how we can work with them. So why should we use sets? First, sets automatically eliminate duplicate elements. Sets don't maintain any order, which makes them perfect for situations where you just need to check for unique values. For example, if you convert a list like 1, 2, 2, 3, 3, 4 to a list, the result will be 1, 2, 3, 4, removing all duplicates. This makes sets particularly handy when you are working with large amounts of data. Now let's look at some common set operations. The union operation, denoted by a pipe symbol, combines the elements of two sets. For example, if you have set A as 1, 2, 3 and set B as 3, 4, 5, the union will be 1, 2, 3, 4, 5. Next, the intersection operation, denoted by ampersand, finds common elements between two sets. Using the same sets, set A and set B will return 3 as 3 is the only common element. Moving on to more set operations, the difference operation, denoted by a minus sign, returns elements that are in one set but not the other. For example, set A minus set B will give 1, 2 because these are elements in set A that aren't in set B. The symmetric difference, denoted by, gives elements that are in either set but not in both. So set A, set B will return 1, 2, 4, 5, which are elements exclusive to each set. Sets have several useful methods. The add method lets you add elements to a set. For example, mySet.add6 adds 6 to the set. The remove method removes an element from a set. But be careful, if the element does not exist, it raises an error. For example, mySet.remove4 will remove the element 4 from the set. On to more set methods, the discard method is similar to remove, but it does not raise an error if the element is not found. For example, mySet.discard4 will remove 4 if it exists, but will do nothing if 4 isn't in the set. The pop method removes and returns a random element from the set. It's important to note that since sets are unordered, you can't predict which element will be popped. Finally, the clear method removes all elements from the set, effectively leaving an empty set. Sets also support set comprehension, a concise way to create sets. Just like list comprehension, you can use set comprehension to create a set from a sequence. For example, x asterisk asterisk 2 for x in range 6 will give 0, 1, 4, 9, 16, 25, which is a set of the squares of numbers from 0 to 5. Let's summarize what we have learned about sets today. Sets are unordered collections of unique elements, making them ideal for tasks like eliminating duplicates. We explored operations like union, intersection, difference, and symmetric difference. We also saw some set methods such as add, remove, discard, pop, and clear. Finally, we learned how to use set comprehension for more compact code. These tools will help you work efficiently with sets in Python.